discussed that already in previous chapters. That vector in the vector space, or vector space is a high dimensional space where we represent our documents. So we have been doing that for our calculation purposes, like for finding out the similarity between the documents. We calculated cosine similarity based on that only. So the basic hypothesis that is there in your vector space model for classification is the contiguity hypothesis. Now, what is that? The contiguity hypothesis, it states that the documents in the same class, they form a contiguous region, and the regions of different classes do not overlap. So the documents which are very much similar to each other, they will be belonging to one class, and thus in the vector space representation, they will be very close to each other. So two classes, or the documents belonging to two classes, will be very distinct and clearly it will be visible. So we had already discussed about text classification using our naive-Bayes classifiers. So this is just a recap. We already had these discussions, and problem solving also we did. So today we'll be discussing about vector space methods for text classification, and we'll be basically discussing using centroids, that is your Rocchio algorithm, and K nearest neighbor algorithm. Now recall that in vector space representation, we were representing each document as a vector, and one component for each term we were considering. Each term means each word. What we had done is we had taken a weight matrix. So term incident matrix जैसा दिखता है, weight matrix में भी वैसे rows and columns हैं. So columns represent a document and each row represents the weights of a particular term in different documents. So we took the document vector and we then normalized it to unit length using our L2 norm. We did that, and then that was represented in your v-dimensional space. So basically the documents, they are vectors in this space, in this v-dimensional space. So many documents are represented there, and there are also many dimensions. That is why there it is known as v-dimensional. Now how do we go for classification in this space? So the training set, it is a set of documents where each document has been labeled with a class. Class means to which category or which group it belongs to. So labeling for the documents has already been done. So training set consists of the documents along with their labels. So in the vector space classification, this set, it corresponds to a labeled set of documents in your high dimensional space. Now the documents in the same class, they form a contiguous region of space, and the documents of different classes don't overlap. So what we need to do here is we need to define the surfaces to delineate these classes in the space, to separate the classes in this high dimensional space. Now let's go through an example. So this is the representation of the documents in vector space. So here each circle, each filled circle represents a document. Now you can see here three different colors of circles are there, which means that three different classes are there. So these maroon colored circles are your documents having the label or having the class government. These blue filled out circles, they belong to the class science, and these four documents which are black colored, they belong to the class arts. So this much, all these collection of documents, this makes our training set. So now suppose we have a test document. Okay, so this test document is there. It has been represented in the vector space. We need to find out that this test document belongs to which class. I have to identify the class. So here we can see that it is very close to the class of government. So since it is very close to these documents, these types of documents, so this tells that this test document belongs to the class government. So we need to find out good separators here so that the documents of different classes don't overlap. So here you can see that this area, this belongs to your documents for the class government. This area belongs to the documents for class science and this one for class arts. So we need to find good separators so that these documents don't overlap. So this is just a 2D representation of the points. Let's discuss your Rocchio algorithm. Now Rocchio algorithm already we discussed in chapter your relevance feedback and query expansion. There what we did, we found the centroid for relevant documents and centroid for non-relevant documents where the documents were represented in vector space. So there our motive was to find out Q optimum. The Q optimal we are finding, we found the distance between the two centroids, that is relevant document centroid and non-relevant document centroid. Whatever distance was there, that distance was further added to the relevant document centroid, and thus we were getting our Q optimal point. So that was all about your Rocchio algorithm, which we discussed in relevance feedback. So for training documents in different categories, we compute a prototype vector. Now, what is the prototype vector? Your centroid vector. By summing the vectors of the training document in that category. And then we assign the test documents to the category with the closest prototype vector based on the distance formula, that is a cosine similarity. So Rocchio algorithm, which was being used in your relevance feedback methods, is now can be used for your text categorization, and this can be viewed as a two-class classification, that is your relevant versus non-relevant documents. There also we took two classes only, relevant and non-relevant, so this is a two. We can use this one for solving two-class problem. Standard TF-IDF weighted vectors are used to represent the text documents, and then we find the centroid vectors, and then the distance, and accordingly we assign the test documents. Now since Rocchio algorithm is a two-class problem, so here two different classes have been shown. So one is your of blue color, another one is of your red color. So these documents, these which are of your blue color, they belong to one class, and these which are your red colors, they again belong to another class. So basically this is one class and this is another class. So two classes are there. Just to separate the classes, to have a clear visibility, two different colors have been used. Now, this is the centroid for the class having the label, suppose red is the label here, and here the label is suppose blue. So for the red class, this is my centroid. Similarly, for the blue class also, we would find the centroid, and this is the centroid. So now we are having two centroids for each class. Now suppose this is my test document. A new document is there, and I need to decide that this document will belong to which class, red class or blue class. That I need to decide. So what I will do here, as written in the previous slide, we will be finding out the distance. We will be using the cosine similarity formula for finding out the distance. So if you remember, we find out the angle and accordingly we find it out. So here we find the distance between the test document and the red class centroid, and we also find the distance between the test document and the blue class centroid. Now, by finding the distance, we see that the distance between the test document and the blue centroid is less as compared to the test document and the red centroid. Now, since the distance is less in this portion, this means that the new document is having more similar features or more similar words or terms with this blue class as compared to the red class. Now, since there is more similarity between this test document and this blue class centroid or blue class documents, therefore, the new test document will now be assigned to the blue class. That is why here you can see the color is now changed to blue. So this is a definition of your centroid. D represents the set of all documents. Now D of C represents the set of all documents belonging to that particular class C. And V of D is the vector space representation of the document. Now you need to remember that whenever we are generating centroids, those centroids are not unit vector. The centroids are not unit vectors, whereas the inputs which we give, the inputs are our unit vectors. Centroids cannot be converted to unit vectors. Now, what are the properties of Rocchio algorithm? So this forms a simple generalization of the examples in each class. The prototype vector, that is a centroid vector, does not need to be averaged or normalized for length, since your cosine similarity is insensitive to vector length. So classification is based on the similarity to the class prototype, that is, it is based on the similarity to the centroid of a class. But it does not guarantee that classifications are consistent with the given training time, the given training data. Now these types of models, like finding out the centroid and then working upon finding out the class and all, so they have problems with disjunctive categories. Like a situation which is like this. So if you have represented the documents and their representation is something like this, then Rocchio algorithm does not work well. Why? Because the centroids, whichever are found, they are very close by. You can see here in this diagram. So for red class, this is the centroid. For blue class, this one is the centroid now. The two centroids are very close to each other. Centroids themselves are close to each other. Now this is my test data, a new document. So what I will be doing right now, I'll be finding out the difference or distance between this test data and the centroids. So now I'm finding out the difference. I'm finding out the distance. And then based on the distance, from here we see that distance between the red centroid and the test document is less. Therefore, we assign it to red centroid. But if you see here, this test document, it is now very much close to the blue document, whereas it is far off from the red documents. So actually, when we represent it, then it is very much close to the blue documents. That means it has more similarity with it. But when we are taking the concept of centroids and finding out the distance, then it is having less distance from the red centroid as compared to the blue centroid. So that's why we assign it to the red class. But here the scenario says that it is more close to the blue class. So these types of situations are very complicated, and these types of situations Rocchio algorithm cannot solve, or you cannot guarantee that whatever solution you are getting that is consistent, that will remain consistent. So Rocchio forms a simple representation for each class, that is for each centroid or prototype. Classification here is based on your distance from the centroid. It does not guarantee that classifications are consistent with the given training data as we saw in the previous example. So it has been effectively used for text classification, but the solutions are not consistent. So those are the features of your Rocchio algorithm, which is used for your text classification and vector space models. Now coming to the k nearest neighbor classification. So this is another technique which is used for your vector space classification. So KNN stands for k nearest neighbor. So let's go through an example. So here what we need to do is you have to classify a document into a class C. So for a particular point, we take k number of its neighborhood documents, find the distance from those documents, and whichever documents have less distance from the new document, then the new document will accordingly be classified or put into that class. Let's take this example. So here k value is equal to 6. So it is 6NN. So the same example which we discussed earlier, that this set maroon filled circles, they represent the class government. This represents the class science, and this black one, they represent the class arts. So now this is my test document, yellow one. So I need to find out to which class it should belong to. So we represent that document in the vector space model, and then since k is equal to 6, so k nearest neighbors, 6 number of nearest neighbors has been taken into consideration. So you can count here 1, 2, 3, 4, 5 and 6. 6 nearest documents has been taken, and then we calculate to find out the distance, and here we see that these are more close by. Also we see that the number of documents within the six number of documents, the number of documents which fall to a particular class or number of documents belonging to the government class are more as compared to the number of documents which belong to the class science. So more documents are having similarity, more documents from the government class are having similarity with this new test document, and therefore this will be allocated to the government class. Nearest neighbor learning algorithm, it is also known as your case-based learning or memory-based learning, or sometimes lazy learning also. The whole algorithm is based on the contiguity hypothesis. Now KNN, it is close to optimal as compared to your Bayes theorem, Bayes classifier. But when we are, this is a case, exceptional case, that when we are taking, when my k value is equal to 1 nn, when we are using that 1 nn to find out the class of a test document, then that may be subject to error. Because we cannot decide the class of a document just by comparing it or finding out the similarity with respect to one document only. We need to find it out by working upon with more than one number of documents. So therefore, as compared to 1 NN, more robust alternative is to find k most similar examples and return the majority category of these k examples. Now the value of k is typically odd, and we need to avoid the ties. So we should not be taking like 8 documents where 4 belong to one class and rest 4 belong to another class. So chances are there we may have a tie, and then again the same confusion will be there that to which class the new document should belong to. So to avoid these types of situations, odd number of documents should be taken into consideration. And mostly the number of documents which are taken into consideration, that number is 3 or 5. These are more common. So these are, you can see here, it represents the KNN decision boundaries. So KNN gives locally defined boundaries between the classes. So the faraway points, they do not influence the classification decision as it was being done in your naive-Bayes and Rocchio algorithms. So the nearest neighbor method, it depends on a similarity metric. Now the simplest one is your Euclidean distance, but also Hamming distance is being used. But for the text documents, cosine similarity is being used instead of your Euclidean and Hamming distance. So this one is the illustration of 3NN for text vector space. You can see here these three documents belong to the red class and these two belong to the blue class. So this is now my test document. Since it is 3NN, so we take three nearest documents. So for this new test document, three nearest are this one, this red one, this blue one, and this one. So these three are the closest to this new test document. So now we find out the similarity distance between them. So here you can see that this test document, after finding out the distance, this one is the least distance which have been calculated. So now it has been assigned to the blue class. So nearest neighbor tends to handle your polymorphic categories better than Rocchio or Nepes. As we have shown, we have seen that Rocchio was unable to handle these types of situations. 3NN can. So here you see we have a test document here. So we find the nearest documents. So these are the three nearest documents. We now calculate the distance between the new test document and this one, the new test document and this document, and new test document and this document. Now after doing this calculation, accordingly this test document is now assigned to the blue class. So this KNN can effectively handle these types of situations. Now these are some of the properties of KNN. So here, usually in text classification, before applying any classification or clustering algorithm, we have to go through some pre-processing steps. Amongst that, one is there your feature selection. So for KNN, feature selection is not necessary. It also scales well with even large number of classes. So even if the number of classes are large, then also KNN can be used effectively. It may be expensive at the time of your test time. When we are doing a testing, that time it may be expensive. But again, in most of the cases, it gives more accurate result as compared to your naive Bayes and Rocchio algorithms. So this is an example, and there's a comparison between KNN and naive Bayes algorithm for text classification. So KNN has high variance and low bias, whereas naive Bayes has the opposite thing. It has low variance and high bias.